Hello viewers, my name is Raj and welcome back to my YouTube channel. So I'm back again with a new video in complete placement preparation series. So before I start my video, so it's a general uh, greeting to all of you that or a warning to all of you that these are unfortunate times and we are facing a big pandemic and there have been a lot of cases of COVID-19 in recent times. So please take care of yourself and try to avoid contact of any unknown person or unknown item as far as possible. So other than that, if you like my content, please like it, share it, and subscribe it. Share it among your friends. So let's start today's video. So this is a problem which is named as two sum. This is numbered as number one in Leetcode. So not in terms of like ranking, but it is numbered as like serialized as number one in Leetcode. So in this problem statement, we are given a bunch of numbers and an integer which is known as target. So we have to find two numbers such that the sum of them from the array such that the sum of the two numbers is equivalent to the target. And if we carefully see, we have to return the indices of of those numbers. So we are not allowed to send the particular number. We have to send the indices, right? So okay, so apart from that, there is a note that we exactly have one solution in this particular setup. So we don't have multiple solutions. We only have one solution. We have to return that. Okay. So and apart from that, there are some constraints. So then length of this particular input array will be from 2 to 10 raised to power 3. The values can range from minus 10 raised to power 9 to plus 10 raised to power 9. So that is a very wide range. And since this is a lead code setup, so there might be some things, but I will tell you the general logic to solve these kinds of problem. Because in any coding round or in any placement round, in there will be whenever an interview asks you this kinds of question, they won't necessarily tell you to code it on a coding platform, but they will ask a general approach and you have to write a pseudocode or a code in your favorite language. So at that point of time, you have to come up with a generalized solution, not for a specific platform. So let's go towards the solution or the approach. So let us say we have this input array and we have the target to achieve, which is 9. Okay. So first of all, the first approach that I have come up or I have in my mind is of two pointer. Okay. A two pointer approach. So it includes sorting as well. So what this approach says is, first of all, we have to sort the array. Whatever the input array we have to sort it. So in this case, the input is already sorted, so we don't require to sort. But since we are writing a code, then it will automatically perform sorting. Doesn't matter if the input is sorted or not. So we will first of all sort this particular thing. So we have 2, 7, 11, and 15. Okay. So after sorting, since the name suggests two pointers, we'll initialize two pointers. So first pointer will be pointing towards the first element and the second pointer will be pointing towards the last element. Okay. So if we sum 2 and 15, what we get is 17. So we will check if 17 is the target number or not. Since it is not the case, this 70 is not equals to 9. So what we will do is, and 70 is greater than 9, right? So if 17 is greater than 9, then we will move this pointer, the second pointer, towards the second last element, right? Since the logic behind this is, if we sort the array in increasing order, so we know that the last element is the biggest element, right? And the first element is the smallest element. So if the target sum is less than the sum of the first and the last element, we can simply say that we are going too far ahead. So and if we so in order to reduce the current sum, so what we have to do is we have to reduce or we have to shift the last pointer, which is pointing to the last element, or the biggest element, we have to shift. If we shift that towards the smaller ones, then we will we will reduce this current sum, and we'll try to match the target. So we are basically we are converging. So we either move from this direction or this direction, right? Similarly, there is also like the reverse case can also help. Let us say in a case where your target sum is 9, right? Okay, and the current sum that you are getting is 8, right? Since 8 is not equals to 9 and it is also less than 9, so in that case we have to increment the first pointer. So by incrementing the first pointer, we are going to get a greater sum than the previous one, because since it is we are sorting it. So if I want to increase the current sum, then I have to increment the first pointer, right? So this is the approach. So so first of all, we have to sort, and then we will use two pointers to converge our sum so that we can get the target sum. And it might happen that we don't have any solution. So at that point of time, both the pointers will converge, and either it will point to the same index in case of if there are even number, or sorry, if there are odd numbers of elements, and in case of even numbers, then you will have the pointers pointing to the consecutive elements. So at that point we have to stop. So that is one more condition that we have to specify in case of no solution exists, right? So if we try to get the time complexity of this particular thing, so we have to apply a sorting algorithm which will cost us order of n log n. So any best sorting algorithm will give us order of n log n time, right? And this two pointer thing will take another order of n time. So this will basically converge to what I can say is, so this will basically be order of, so the time complexity will be order of n log n. Okay, so time complexity is fine. And if in terms of space complexity, it depends. If we are using merge sort for sorting algorithm, then we need to have extra order of n space. If we are not using merge sort, or if we are using quick sort or other algorithm, then there is no required to have extra space. It will be order of 1 only. So that is one thing. So this is the first approach. Okay, but there is some trivialness, and we can improve, because in this case, if we see, if the input, it doesn't matter if the input is sorted or not, we are sorting it. So we are basically taking n log n time for not just pre-processing thing. And also in this particular Leetcode example, we have to return the indices, so we can't shuffle the elements. So that is one more constraint, but for general solution this is fine. So moving on towards the optimal solution or the best solution. So this is using hashing, right? So in this example, if we directly see what we are trying to do is, we are trying to find two elements such that the sum of the two elements is equals to the target, right? So here T represents target and S represents sum. Okay, so we are basically finding the two elements. So what I can simply say is, if I can go through the elements, and if I try to somehow remember it, it solves my problem. So what I am trying to say is, if I am traversing through the list, and if I know that I have 2, I have 7, then I can let's say in this case that sum is 9. Let's say this sum is 22, right? So we are trying to get two elements which sums up to 22. So if I am traversing and I know that I already have 2, 7, 11, and by the time I reach 15, so I can simply know that, okay, so I have 7 in this particular array. So if I add 7 to this 15, I get 22, right? So if we try to somehow get the knowledge that we already have this element, and we are trying to look for this particular set of this particular element, then it simply solves our problem. So that's why we use hash. We can use hashing to solve our problem. So what the approach says is, you first see a particular scan the particular item or the element. We first of all check if the okay, so let's say our hash set is termed as h. We are using a hash set which is named as h. So first of all, we will try to get t minus. We will basically check if the nums of I. So nums is the array and I is the pointer. So we'll basically check if target minus the current element is present or not. So what I am trying to search is, let's say if our target is 9 and if I am scanning 2, so what I have to check is if 7 exists or not, right? If I have 2 in my hand and I want to make it up to 9, so what I need is 7. So if I check that if 7 exists or not in this particular hash set, then it simply solves my problem, right? So I will check if 7 exists or not. If 7 does not exist, then what I have to do is I have to simply remember the current element, which is 2, with its index, so that I can have a memory that okay, I have seen this particular element. It might not be useful for now, but it might be useful later, right? So that's the particular approach. Similarly, if you do this again and again and again, so in the next iteration itself, if we are having 7, so in this case what we'll try to check is 9 minus 7. So basically if h of 2 exists or not. Since h of 2 is already existing in this particular hash set, because we remembered it in the last iteration, so what I have is I have the pair of 7 comma 2, so which is sums up to 9, and this is our solution. Okay, so this is the approach. So basically we will remember if the complement is like the other counterpart, after which if we add that we get the solution. So if the counterpart exists, then we can simply return the output. If the counterpart does not exist, then we will simply remember that particular element. So that's the approach. So let's try to code this in. Before that, the time complexity. Since we are using hashing, so all the accessing operations will be of order of 1. So, and this will be around a time complexity of order of n. So we have improved from order of n log n to order of n, but we have compromised on space. Since we are using hashing, so we will have an extra order of n space, but it doesn't matter because order of n space complexity is fine in this problem. And but we have somehow reduced the time complexity, so that is more important. So let's try to code this thing and see if the approach works or not. Okay, so first of all we will define a hash set, or in Python simply dictionary, so which is named as num underscore hash. After that we will simply iterate through all the elements in the array or the list using their indices. So nums of range, length of nums. So nums is the input array. If num underscore hash target minus nums of I does not exist, sorry, not this way, but we have to use the get, since it might happen that the number is not exist in this particular hash. So we will get a key error in Python. So if we want to avoid, then we have to use get. So get will return none if the number is not present, else it will return the particular index. So if that does not exist, then if the number is existing, then we have to simply return in a list which is I, which is the current index, and the num underscore hash of target minus nums of I. Okay, so if this is not the case, then we have to simply remember the current element. So I have to do that. I is nums of I. So we have the value. We will save the value using that index. So value will be the number will be the key, and the index will be the value. So and at the end we will have to complete the code by simply returning null. The empty array. So this is if this is for the case where there is no solution exists, but in Leetcode that is not the case. So let's try to run this thing and see if this codes work or not. So there is a small error. Okay, so this I made a small mistake. So this should not be a list, but it should be a number. So now this code should work fine. So this is working fine. So let's try to submit this and see if this is getting submitted or not. So yeah, it is submitted and it is better than 58% of the online Python 3 submissions in time and better than 72 in space. So this is a very good solution. So I hope you have liked the content. So if you liked it, please subscribe the channel and share it among your friends. Also try to, if you want to give a feedback, the comment section is open. I'm always open for feedback. So thank you and take care of yourself.